Okay, I want you to picture the most silent place on Earth. You know, a huge, frozen landscape stretching out as far as you can see, where the only sound is maybe the wind. Now, imagine a noise that just completely shatters that silence.
And no, it's not a storm and it's not an avalanche. It's the sound of a glacier giving birth. And today, we're going to dive into exactly what that means.
So this whole phenomenon we're talking about has this fantastic name, iceberg calving. And honestly, it's one of the most powerful and dramatic events in the entire natural world.
So what is it, exactly? Well, calving is that precise moment of separation. It's when a massive piece of ice, a piece that's been part of a glacier for thousands of years, finally breaks free and just crashes into the sea. And right there, it begins its new life as a free-floating iceberg.
Now, the name itself is pretty interesting. I mean, why calving? Well, the people who first watched this happen saw the parent glacier as literally giving birth to a new, smaller iceberg, a calf. It's a surprisingly gentle name for such an unbelievably violent event, isn't it?
But yeah, the scale of these events, that's what's truly mind-boggling. We're not talking about a few ice cubes plopping into the water here. We are talking about literal moving mountains.
The biggest of these newborn icebergs could be hundreds of meters tall. And to put that into perspective for you, that's well over 1,000 feet. So taller than the Eiffel Tower, taller than pretty much any skyscraper on the planet.
And their length, that's even more impressive. We're talking several kilometers or multiple miles long. So forget a skyscraper. Try to imagine a chunk of ice the size of Manhattan just breaking away all at once. That's the kind of magnitude we're dealing with here.
And an impact that big, well, it has huge consequences. That thunder we mentioned, you can hear it from miles around. The splashdown displaces so much water it can create actual tsunami-like waves. And once they're floating free, these giants are such a serious hazard for ships that they have to be constantly tracked by satellite.
But the story doesn't end when the iceberg hits the water. Oh no, in fact, that's just the beginning. What we see floating there on the surface, that's only a tiny fraction of the whole story.
You see, before an iceberg even calves, it's had this epic history. The ice it's made of isn't just frozen water, it's ancient snow. Snow that fell, got buried, and then was compacted under its own colossal weight over thousands and thousands of years, forming that dense, blue ice you see in a glacier. So every single calving event is really the final chapter of a very, very long story.
We've all used that phrase, right? Oh, that's just the tip of the iceberg. Well, it turns out it comes from a very real and very dangerous physical reality. It's not just a clever saying, it's literally a law of physics. And here's why that phrase is so spot on. Because ice is just a little less dense than salt water. About 90%, 9G, of an iceberg's total mass is hidden beneath the ocean's surface. What you see, that colossal mountain of ice on top, that's only 10% of the true giant lurking below.
So these are absolutely incredible natural phenomena. But why does understanding them matter so much right now? Well, it turns out their ancient story is deeply connected to our modern one.
And we really can't talk about the impact of icebergs without mentioning the most famous maritime disaster in history. The iceberg that sank the Titanic is this stark, historical reminder of the immense power these silent giants have always had. And that was the danger of a single iceberg. Today, the story is much bigger.
And here's the most critical takeaway from all this. Iceberg calving, by itself, is a perfectly natural process. It's just part of a healthy glacier's life cycle. The problem is what scientists are seeing now. In many parts of the world, the frequency, the rate of these calving events is speeding up. As the climate warms, meltwater can seep down to the bottom of a glacier, kind of acting like a lubricant that makes it slide toward the sea faster, which makes these breakoffs happen more and more often. That natural cycle is being thrown out of balance.
So we end with this thought. These ancient, powerful icebergs are a fundamental part of our planet's system. But if their birth rate is accelerating, what does that signal for the future of our oceans and for our world? It's a massive question, and it's one that a simple piece of floating ice forces all of us to consider.